Hello, today I'm going to talk about how we can overcome the problem that Knight described as a dark secret of AI. Namely, no one really knows how the most advanced algorithms do what they do. In other words, how can we explain why the system make predictions the way it does? But before I actually jump to discussion, I guess we need to look at what exactly we mean by explainability, because there could be multiple definitions in the literature. So if we go back like 10, 15 years ago, um, expert system could be considered as the more or less completely explainable systems. So basically we had an inference engine. It was leveraging a knowledge base to make some assertions. It could then explain all of the chain of reasoning, and then it led to a particular decision. The engine basically was built completely on top of subject matter expertise, so it was powerful and somehow it was restrictive. It couldn't give us the same wiggle room as we have with some modern machine learning systems we have. The modern machine learning approach, especially deep learning, is kind of in an opposite way of a spectrum, where we have a system which could operate purely from the data. You don't need much of a subject matter expertise, and the system can basically learn to produce their own representation of the data, and this representation could be used for predictions. So this creates a issue where the end user doesn't understand the um, system at all, and basically treats it as a black box. And we also have a little ability to debug this system and refine the system behavior, and also we don't know how to prevent some of the systematic undesired biases that could be from the data. Um, Basically, we kind of need a new machine learning system where we will have some kind of explainability. So if you think about examples, probably you need some kind of explanation when you have a very serious decisions from such kind of system about, let's say, your medication or like your surgery, and you need some kind of explanation from the system that could be verifiable by an expert step by step, and not just a bunch of statistics from the previous experiences. And the same could be said about some autonomous vehicles, where we need some kind of understanding of all of the steps the system does in some critical situations, where we want to minimize the casualties and potentially correct some system decisions if it's needed. So basically, explainable AI plays itself in a intersection of machine learning, human-computer interaction, and user explanation expertise fields. Um, there is also an interesting dilemma of different machine learning models, performance, and explainability. And the deep learning is actually the most notorious one, where we have really good performance but really bad explainability. And basically we need to solve this problem somehow, and also this uh, we we should not compromise on the performance of the model. So one of the ways what we can do here is we can actually try to extend the current deep learning model um, to have some kind of inference from that, or we actually can have a model agnostic approach where we can actually treat the system as a black box and try to create a explainable system out of it. Um, one of the examples of deep learning explanation is the learning semantics association system, where it basically tries to tease apart what is happening within a neural network itself. Basically, here is an example. We see how the learning semantics association could be applied to a video stream. And here, for each of the video scenes, basically the system could try to pull out all of the information it could get for the scene. It could be OCR, object recognition, audio, action recognition, and some other techniques, and feed this information into stacked convolutional layers of network for classification. Basically train it a bunch of times to associate the semantics attributes with specific hidden layers. And we train it basically to associate labeled nodes with known ontologies, and those ontologies will be provided by human labeled ontologies. And we use this to generate some examples of prominent unlabeled nodes, so we can basically discover the labels that we should be applying. In other words, basically it will try to learn the labels and try to create ontologies for different scenes and different parts of the video. So in the example here, we see that there are different scenes from the video of wedding. So we basically look at that and we try to understand what is the evidence that it is supporting that we believe it is a wedding video. So basically it looks into actions. It does see that there is a bride, there is a groom, there is rings, and there is an exchange of rings. But basically, instead of just classifying that there is an action that places the ring on the finger, it tries to associate this video with the whole ontology, where it basically tries to create an ontology which has all of these different meanings. So this basically scene contains ring, groom, and bride, and it means that probably some other expert could say like, oh, this is the wedding or not. So basically this system provides some kind of a mix of subject matter expertise and a learning system. And basically this system also could be used for searching for certain events or certain regions inside the video stream. Another example could be local interpretable model agnostic explanation, or LIME. And local here means that we use some kind of local approach. In this case, we use local approach in the image. Basically, we carving up the image into the sections we should make explanation from. And basically the problem is sometimes we have a very complex picture. Here it is like presented the picture of the frog with some object, and it could be really tricky to classify it globally. So the picture, the system could try to use the local superpixel groups and take a weighted random sample around it, remove other pixels, and feed it against the feed it into classifier and test this classifier against what it thinks about the basically global thinking about the picture. So you see here that sometimes it's classified it as a frog, sometimes it's classified as a different object, like a pool or like other objects. And basically to a person which doesn't have any expertise in the field, basically he can understand that the system is trying to classify and it's trying to use different parts of the picture, and this is how it basically associates different parts with the object. So basically the expert in the field or not expert in the field could see all the biases of the system and basically try to understand how the system works for different pictures. I know that this the line could be also applied to the system model, and also it is model agnostic. So basically, we don't need to know exactly what kind of if it is like a deep learning model or other models were used uh, for this classification. Okay, it seems like I'm running out of time. I hope this video was useful. Thank you, and thank you for listening.